Well, first off, thank you everybody for being here. I stupendously enjoy Monitorama. This is such a great event. I love ops people. I've been an ops guy for 10 years or so in a ton of different companies, big companies and small companies, except for a few years ago when I freaked out and joined the Peace Corps. But even then, I still ended up doing development and operations, and so I came back and it turned out that I really, really enjoyed this kind of stuff, so I'm just super excited to be at Monitorama. So really thank you for everybody who brings all of the kind of practical skills and tools that we've seen over the past couple of days, as well as fantastic theory that gives everybody with practical tools and ideas, new ideas to implement. So I'm really excited to take some of the stuff that I've heard in the talks and apply it towards stuff we're doing with logs. Also, thank you to Austin. I don't know where you went, but thank you for the great logging lead-in. Who has used Kibana at some point? Why do I need to give this? Okay. Okay, well, for those who haven't used it, you're probably going to see something new. For those who have used it, you will hopefully also see something new. I'm going to go over kind of a typical use. Who uses it with Logstash? Okay. Who doesn't use it with Logstash? You just use it for other stuff. Okay, so good. Mostly Logstash users. I'm going to talk about a Logstash use case today. I'll talk about a non-Logstash use case too. People who have met Jordan at some point at a Monitorama or seen him on Hangops or something? Anybody? No? Okay. Nobody? Sweet. Okay, a few people. Jordan's a really nice guy. He likes to say that logs are anything with a timestamp, which tends to be very true, but really there's other kinds of data that are relevant to things with timestamps that don't have timestamps. So we're going to go over a really brief non-timestampy use case, and if I get a little bit of time at the end, I'll try to show off some of the new stuff that we've got coming. Okay, well, let's get to it. So what am I looking at now? Well, this is the first screen you would get to if you had just installed Kibana. I know a lot of people have already installed Kibana, so you probably know that there's not a whole lot to the installation process. For the purpose of this demonstration, and because we've only got 45 minutes or so here, I'm not going to go through setting up Elasticsearch or setting up Logstash. They're both pretty easy. Logstash has a fantastic 10-minute tutorial to get you started, and Elasticsearch is really one command to get going. Kibana doesn't even have one command to get going. You take this, untar it to a web server of some kind, Apache, Nginx, Lighty, some terrible thing you made out of Netcat just to see if you could. The fact is that you don't need mod PHP or mod Ruby or Node. Every now and then I get somebody that asks me, oh, well, it's just all JavaScript. Well, what do I run Node against? Nothing. You don't run Node against anything. You don't need Node. It's all HTML and JavaScript. It talks directly to Elasticsearch. Elasticsearch, if you haven't used it, is a great search technology that is distributed and sharded and can scale up really, really nicely. But for developers, it has a really great REST interface. And so older versions of Kibana had a Ruby backend. Well, that Ruby backend was really just a REST interface, right? And so I had JavaScript that was talking to my REST interface that was talking to my REST interface. So I didn't need a REST interface in my REST interface. So for Kibana 3, we decided, yeah, okay, exhibit. Thank you. Anyway, for Kibana 3, we decided let's go ahead and just make this talk directly to Elasticsearch. So that's what it does. So what do you actually need to get started with Kibana? The most important bit is a good web browser. People currently using IE? Raise your hand. Right. That's what really, is there nobody? Oh, that's awesome. Okay. Anyway, even if you do use IE, IE9 is fine. IE9 and above we support. The latest version of Chrome or Firefox, Safari, all fantastic. Like I said, you need a web server. It just needs to serve static files. There's no server-side component to deal with here. And you need Elasticsearch, of course. Elasticsearch is the one data thing that Kibana talks to. You need version 0.90.9 or above. That's not to say I recommend that you use 0.90.9. I really recommend that you step it up to Elasticsearch 1.1. It'll leave you in a better position for upgrades. We'll probably stop supporting 0.90.9 soon. I can't promise when, but Step it up to at least 1.0. If you can, 1.1. It's way more memory efficient. There's a ton more features. Kibana does some amount of feature detection in Elasticsearch, so it'll turn some stuff off if it's not supported. So, don't leave yourself thinking, hey, where'd that button go? Okay, as far as configuration goes, there's really not much you have to do here. If you're installing it on a host that's different from your Elasticsearch host, there's a file called config.js that you have to jump into and change the Elasticsearch host. But if it's on the same host as your Elasticsearch server, you don't even have to do that. It comes pre-configured to talk to Elasticsearch on the same host you're accessing it on port 9200. Okay, so we're going to assume here that you are a Logstash user, and at least for the purpose of this first kind of run through, we're going to assume that you're a Logstash user. So you can see down here, we've got the question, are you a Logstash user? And I'm going to say that, yes, I'm a Logstash user, and I'm going to click on the Logstash dashboard. Okay, the demo gods did not smite me. Thank you, demo gods. I managed to do that without taking the life of a chicken or a goat or burning any incense. So thank you, demo gods. All right, so what are we looking at here? This is kind of the default interface. This is probably very familiar looking to you. There's a lot of interfaces that look a lot like this, but nonetheless, I'll start off and kind of give you a quick walkthrough of it for those who haven't seen it before. In the top left-hand corner here, we have the name of the dashboard. And when I say dashboard, Kibana calls everything a dashboard. All of the interfaces are called dashboards. And I know when we think of dashboards, we tend to think of a thing that's up on a big screen that nobody really touches. We compose it once and then we never play with it. That's not really how dashboards in Kibana work. You can use it for that. You can get rid of all these little interacty bits and just kind of throw it up there and never touch it again. But Kibana is very much so designed to be interacted with and to be used for exploring data. So nonetheless, we call everything a dashboard. Okay, so there's the name of our dashboard. It's the Logstash search dashboard. Over here, we have a time selector for picking out relative time frames or a custom time frame if you need an absolute range. So we can say, show me just the last 2 days of logs or show me just the last week of logs. That's interesting. Okay, we have a refresh. If you just need to refresh the page, reload data. We have a home button that'll take us back to that main introduction page. You can also change where that takes you on a user-by-user basis by going to Advanced under this little Save button and click Save as Home. Save is, of course, for saving dashboards. These get persisted back to Elasticsearch. We store the schema for the dashboard so that they can be searched and reloaded. If you want to search and reload it, there's a Load button there for loading up anything that you have saved. There's also a Share button for sharing temporary URLs. This stores a temporary dashboard in Elasticsearch for 30 days. Gives you a nice little short URL for sharing with coworkers. Maybe you have entered a search or something and you want to show them the results. You can use that to do it. The most important button in that top bar is probably the configuration button here. So I'm going to quickly click on that and give you an overview of what's going on in there. Okay, so changing the name, that sort of stuff. I'm going to quickly change the style here from dark to light and hope that it's a little bit easier to see. Is that a little bit better? Okay. That's what I thought. All right, so let's go with light, and let's also go back into Configure Dashboard and look at a few more settings. Okay, so there's general settings. Index settings, there is not a lot in here right now, but these are pretty important settings. Right now, I have this set to just look at logstash-star. This isn't how it comes by default, honestly. By default, it comes like this. Click on timestamping, go down to day. So what does timestamping do? Well, for those of you who have used Logstash, you may have noticed that it creates a lot of Elasticsearch indices. It creates an Elasticsearch index for every day that you have logs for. So every day at UTC midnight, it creates a new index. What it does is it takes Logstash dash and it appends the day to it, or the date with the year, the month, and the day. This is important for two reasons. A, it lets us really easily clean up old events in Elasticsearch. Elasticsearch has a feature called delete by query, where we can say, well, delete anything that has a timestamp from this to this. The issue with doing that is it has to go look for all those events, whereas we could also just issue a delete command to the REST interface and just delete the entire index, in which case it's just blowing things off of the disk and it's really fast. So this is nice for cleaning stuff up. Even better than cleaning stuff up, Kibana uses it as an optimization. So you can imagine if you're storing everything in daily indices, it's really easy to tell what index might have data for the time range I'm looking at. If I set the time range to the last 2 days, well, I know that any index that has a name that's more than 2 days old couldn't possibly have any data in it that I would ever be looking for. So Kibana takes that time filter that you set, so right now I've got it set to last 7 days, but maybe if I had it set to last 2, it would only look at May 7th, May 6th, and May 5th, assuming we've got a full 48 hours there that overlaps into 3 indices, but we would only search those. Not only would it only search those, but it searches them in a reverse sequential order. Okay, well, what does that mean? So I'm going to click Save here, which is going to rerun the search. So you can quickly see what happens there. What happens is that Kibana goes through and it hits each of those indices one at a time and builds up the results. The benefit of this is that our time to first byte is a lot faster. We're not searching through stuff that, A, we're not searching through stuff we don't ever need, and B, we're getting the most recent stuff first. We take the guess that if you're looking through logs and you're looking at a relative time range, the thing that you're probably interested in is the thing that happened the soonest, so we hit the newest index first, and then we kind of backfill things in. So like I said, the benefit of this is time to first byte is a little bit faster, or quite a bit faster, but the actual search time is slightly longer. So for the purpose of the demonstration, I'm going to disable it. It also, timestamping indices also has the benefit of reducing the load on your Elasticsearch cluster, because once again, you're not loading up data that couldn't possibly have anything you're actually looking for in it. And this matters a lot more if you have a lot more data. When you start to get up into the billions and billions of events, this really starts to matter to only look at a small segment of stuff. Okay, so we've got our dashboard here, and we've kind of configured a few things, at least looked at a few configuration items. Let's talk about actually using the dashboard. Okay, so below that we have a query bar. This takes Lucene query string syntax. Any Lucene users in here? Ever used? Okay, people who have used Lucene query string syntax? I would assume everybody who has used Kibana would probably raise their hand here because that's what it supports. Elasticsearch also slightly extends the Lucene query string syntax to make it a little bit easier to use. So I can do stuff like search for bytes greater than, say, we'll do 1 megabyte here. Okay, and that'll give us back, right now we're searching through HTTP logs. So there's every request that was greater than a meg. Okay. Down below it, we have a chart here of events over time, and below that, we have a listing of logs. Now, this is just awful, right? I mean, I could cat out a file on disk and have exactly this, and it would be awful, and I would have to use grep, and sed, and awk, and who knows what else, and attempt to columnize it, and attempt to search through it and make things how I want them to look. And that's just miserable. And of course, since we've already parsed out a whole bunch of fields from our syslog data, we're not going to do that. So instead of looking at this big blob here, what this is the raw JSON event that's stored in Elasticsearch. If we click on it, we can see a breakdown of fields. So these are all the fields that we have available to us. We can also look at the entire raw JSON event if we would like to. This really is not an ideal way to look at logs. There's a lot of noise in here. This takes up a lot of vertical space. I mean, if we look at this, we're only looking at one log event here and it's taking up the entire screen. That's not useful. So let's go ahead and collapse that and let's just look at the data that we're interested in. So timestamp is important. So ISO 8601 timestamp. Client IP, also very important, who requested the page. What did we tell them? Let's get the response code. Let's see, request, what did they ask for? And we'll leave it at that. All right. Okay, so this is a little bit better, right? We can actually make comparisons between individual log lines. This is much simpler than trying to grep through a raw log and trying to figure out what position everything is in a perhaps regularly formatted, perhaps irregularly formatted log. This is much easier. Okay, so maybe we want a little bit of data on what we serve, right? So we've already looked for bytes over a megabyte, or pages served that were over a megabyte. But what is our average page size, right? We serve up a lot of pages. Within the last week, what is the average page we look at? How much data is that? You can imagine doing this with sed and awk and something, and imagining how long it would take you to sum a list of numbers of bytes of all of your page hits over the last week. It would be miserable. You'd have to write a horrible script for it. We don't have to do that. Let's click on bytes. Gives us a little breakdown of all the different byte sizes, or at least the top 10 different byte sizes we have over here in this table. But that's not really what we're interested in. What we're interested in is computing some statistics. So I'm going to click on this stats button. Okay, so there is the average size. And actually, I'm going to take this, and I want to add this to my dashboard. So I'm going to take this and drag it up here and drop it up there. All right, so I'm going to close that. I've added that to my dashboard. Now it's a permanent fixture there. I find this kind of hard to read, especially since I'm looking at bytes. So I'm going to click on this little configure icon up here. Every panel has one of these. It's got a configure icon, a drag icon, and a remove icon. Some of them also have this handy little inspect icon. I'll actually quickly show you what that does. What this does is it gets you the last Elasticsearch query in a curl form that that Kibana had to run to get that data out of Elasticsearch. Really handy for writing shell scripts or checks or something when you're trying to figure out how do I get some specific number out of Elasticsearch. That can be a good place to go. Okay, so let's make this look a little better. So I'm going to click on this configure icon. Okay, I clicked on configure, and I'm going to go over to panel, and I'm going to choose to format this in a different way. Right now it's just formatted as a kind of pretty printed number. I'm going to instead change this to be formatted as bytes, so I can view it a little better. Okay, so 3.78 megabytes is our average size request for a page. All right, so maybe I want to do a little bit more searching here. Logstash has this really great GeoIP filter. Has anybody used the GeoIP filter? All right, so the GeoIP filter is awesome, right? It takes IPs that come into your logs, looks them up in a MaxMind GeoIP database, and pulls out a little bit of geographic information. You can download the databases from MaxMind's site. They have a couple of different sizes of them. I've loaded up one of the smaller ones because I was really only interested in country codes. So I'm going to search for some country codes. I want to look for stuff that's in the US. Okay, so there's all of my US users, and I can see my US users on average load bigger files. Okay, interesting. Let's also search for, let's do Brazil, and let's pick big countries. We'll do China here, and can we fit one more? Nah, we'll just leave it at Brazil and China. Okay, so US, Brazil, and China. Okay, so there's our graph again, and now you can see that we've added a couple more series to this, right? We added 2 more queries. We changed the first one, and that added series to our graph. So we have this graph here, and we can see a couple of outliers, right? I can see a kind of blue spike here that I wouldn't normally see, and I've got a big yellow spike over here that's a little weird. And I'm kind of wondering what was causing those. So, like I said, Kibana is designed to be interactive, so let's interact with it a little more. Kibana allows you to pick out stuff on this chart and like zero into stuff. So let's do that. I'm just going to take my cursor and just click and drag and select part of the chart. So I'll just select those 2 guys. Okay, so I've got the small kind of outlier over here and a bigger one over here. I'm going to maybe get into this one, although I don't really like stacked bar charts. This is how it ships by default. They're good for seeing totals of stuff, but I prefer something slightly different. So I'm going to get rid of the bars, and I'm going to add in lines, and I'm going to unstack it. Okay, so I like that a little better. I could also change the resolution of this if I wanted. Maybe I want something that's, finer grained, but I don't really. I'd rather stick it on auto. All right, I'm going to select this kind of smaller outlier here. Grab that, and just that. That's all I'm interested in. Okay, so now I've just got that chart. So what did I actually do here? What happened was that as I zeroed in on this, Kibana started adding filters to the view of the dashboard. Filters are kind of a global thing here. So when I started adding filters, it filtered down this panel. It also filtered down my table panel, so I'm only looking at the stuff that kind of makes up this big blue blob and a couple of green blobs and a yellow one down there. All right, and to make those filters, I added a bunch of filters up here, and these let me kind of go back when I need to. So I can get rid of these two filters because these are broader than this one, and I'm not really going to want to go back to them, so I'm just going to ditch those, clean things up a bit. And I can toggle these on and off as well. So right now I'm looking at, a very narrow view. I can unnarrow that by toggling. All right, we'll go back to the overall view, but for now we'll keep it zoomed in. All right, so we're trying to figure out, well, what happened here? We had a big blip in the total amount of traffic we were getting to my site. These happen to be logs from logstash.net. So what caused my blip here? Well, I could kind of dig into this. Maybe this was just one user, right? It's unlikely that, what is this, China? Yeah, it's unlikely that a large portion of China suddenly found an interest in logstash.net for the period of, 12 minutes? So chances are this was probably just one user. So let's figure out, was it just one user? Let's go down and let's look at client IP. So I'll click on client IP here. Yeah, so just one user is responsible for the vast majority of this, we think. Important thing to note about this little panel here is this analyzes the stuff that's in the table. So really the stuff that's in the table, assuming we're sorted by timestamp, might just be this little bit on the end here. So we have buttons down at the bottom here, in particular this terms button, that lets us analyze the entire view of the data set. The reason we do it like this is because running these terms operations can be kind of heavy. I don't want to unnecessarily overload your Elasticsearch cluster, so we separate it out. All right, so I'm going to click on terms, and I'm going to see a bar chart of all the client IPs that are, or at least the top 10 client IPs that are present in that set. So click on bar chart here. Okay, there we go. As we can see, 115.100.62 is responsible for the vast majority of requests here. I can click on this and add another filter. All right, now I've just got a big green blob, so I'll get rid of that. And we can see that, yes, 115. Whatever it was is responsible for most of it. We can see that it was definitely in China, or rather is responsible for all of it. We've also added a terms filter up here on clientip.raw to match that value. So we can see indeed this user maybe ran a script or something to scrape the site. We can grab down into the logs and figure out exactly what they were doing. If we look at response, we can see that everything they requested was a 404. And if we look at the actual things they requested, let's see, they are all PHP files of some kind with a query string parameter for another site. So maybe they were scraping for sites that allow anonymous proxying or something through a URL parameter. Or perhaps reflexive cross-site scripting vulnerability, something like that. All right, so that was a fairly easy problem to solve, right? We can imagine if we had to do that with sed and awk and grep, it would probably be miserable. All right, so we looked at a kind of pre-built dashboard sort of thing. I'm going to clean this up a bit. What if we wanted to build something entirely from scratch, right? Maybe I'm not a Logstash user, or I have some data that isn't necessarily logging data, and I'm not interested in all the kind of time-specific stuff we've got here. All right, let's do that. Let's go back here, we refresh that. All right, so let's start off with just a totally blank dashboard, right? Instead of jumping into the Logstash dashboard, I'm going to go down here to blank dashboard. We've also got a couple of other dashboards to kind of try to get you started. We have a sample one. This just runs a terms facet to try to figure out what types of data you have. So it looks at the Elasticsearch type field and tries to give you some guidance on what data you might have. I already know what kind of data I have. There's also an unconfigured one. This is largely just a bunch of text panels kind of guiding you through building something, but I'm here to kind of guide you through building something, so we'll skip that. All right, so let's click on blank dashboard. Okay, we've got nothing. We've got a querying bar, we've got a filtering bar. Other than that, we have no outputs. It doesn't matter what I type in this query box, nothing's going to get run because there are no outputs. So let's go through and configure up an entirely blank dashboard. Okay, so I'm going to click on configure over here, bring down the configuration, and the type of data I'm looking for, I grabbed the open beer database. If you jump into my GitHub repository, there's a repository, I think it's called data, and it's got all of this in there. So I'm going to call this beers of the world. Okay, and we'll change this back to light to make it easy to see again. All right, so I changed the name to beers of the world. Oh, I also want to configure the index that I'm looking at. Okay, there's no timestamping to be done here. This isn't timestamp data. By default, I'm looking at _all. That can have a lot of data in it. I'm going to restrict that to just my beer index. And I'm also going to select this box over here called preload fields. I turn this off by default. What it does is it looks at the Elasticsearch mapping for whatever index you put over here. The Elasticsearch mapping is the thing that informs Elasticsearch how to treat fields and also what fields are present in documents. Kibana can use this data to decide what functionality to make available for individual fields and to help you do nice things like autocomplete when you're typing stuff into configuration. So I'm going to turn on preload fields. Okay, and then I'm going to save that. Okay, so now again we have a pretty blank dashboard, but we've started to configure it at least. So Kibana dashboards are made up in rows and panels. A row can have as many panels in it as you want. These are hideable, movable, and whatnot. Let's go ahead and just add one row for now. I'm going to add a row, and I'll just call it beer table. Change the height of it, make it 250 pixels tall. This, by the way, is a minimum height. If panels need to overflow it, if they have a ton of data, especially like tables and such, they'll kind of push everything down. All right, we'll create the row and save that. Okay, we've got a row. Let's add a panel to it. And we're just going to add something simple for now. We're just going to add a table for now. Oh, I should probably go back and say what I actually did there. I clicked on this Add Panel to Empty Row button. There's other ways to accomplish the same thing. If you move your mouse over to these little colored boxes here, there are 3 small buttons. The blue one collapses the row, so this would hide any panels that were in there. When rows are hidden, there is no querying that happens in them. So if you have some particularly heavy operation in the interface and you don't need to see it all the time, you can hide the row. It won't perform any queries for any panels that are in there. All right, let's re-expand that. There is a configuration for the row. This is changing the title of it or adding panels to it. And there's also a quick Add Panel button. So I'm going to click on that and add a panel. All right, let's select a panel type. For now, I'm just going to select a table. Okay, so we get a few configuration options. The only one that we're really interested in right now is this span option. Kibana has 12 spans that go across it. So we have a selector of 1 to 12. 1 would be unusably small, and 12 is really quite large. So let's go with 12. I want it to span the entire width of the page. All right, so I'm going to add a table. All right, so again, we're looking at something pretty familiar here. It's just a table of records. Obviously, I don't have a date histogram or a time series chart up here because this isn't time-based data, but I can still columnize this. So let's quickly columnize this. I need to look at, let's see, how about the name of the beer, the name of the brewery that brews it. I want to see what country it's brewed in. How about what state it's brewed in as well, and how strong it is. So ABV. There we go. All right, well, right away I see something kind of weird with my data. I've got a lot of zeros over here. This is likely because my data is somewhat incomplete, so I'm going to strip out some of those. So up here in the query, I'm going to say minus, so must not have ABV as 0. Okay, so we got rid of everything that was we didn't have data for or was non-alcoholic, which I'm also not interested in. Okay, let's sort this because I want to see how strong these beers are. Okay, I'm really hoping the Norfolk Nog Old Dark Ale is an error of some kind, because I'm pretty sure that would make you go blind. Okay, let's restrict this to a slightly more reasonable range. Let's do ABV of 1 to upper limit here. I'm gonna go with like 12. That's a really strong beer. Let's do 12. And I'll get rid of the minus here and change that to a plus, because that's the range I want to see. Okay, there we go. So we kind of restricted things, made it a little more sane. What I'm looking for here is, I'm in Oregon, and I've done this a few times for states when I'm interested in what sort of beer they brew in specific states. America has a great beer brewing culture. I don't think there's any other country on earth that has as many beers as we have and brews in as many styles. And different regions can have different styles, but let's try to figure out a little bit about Oregon style beers. So I want to look for plus state is Oregon. And you notice I'm using a shortening of the actual field name here. So I used just state here, when really the field is called brewery.state. When it comes to querying with Lucene query string syntax, I have two options of how I want to address the field. I can address it either by the entire name, so brewery.state, or I can do it just by the leaf node. What I can't do is do it by like a partial branch. So let's say I had brewery.location.state. I could refer to that either as brewery.location.state or just as brewery, but I can't put in, say, location.state. Just something to know about. Okay, so let's do state Oregon. Okay, so now we've got just stuff that's in Oregon. And I want to know a little bit about Oregon style beer. So I want to know, well, of the different types of beers, and I have a field called category down here, I want to know what category Oregon style beers fall into. So I'm going to click on category, and I'm going to run a terms across it and throw a bar chart up here. Okay, so largely North American ales. I'm going to take this and I'm just going to drop it on top of the table. Rows are allowed to have as many panels in them as you want, so this will just add it to the existing row with the same width of the table panel it came from. So I'm going to close that. The other thing I need to know about Oregon style beers is how strong they are. So I'm going to jump into ABV here, and I'm going to run a statistical facet across it. Okay, great. I know that it is that beers in Oregon on average are 6% alcohol. Okay, what I don't know is what types of beers are how strong. And this is something Elasticsearch can do. So what we've done here is we've run a terms facet and we've run a statistical facet. Elasticsearch has a facet called the terms stats facet that combines these two, and we expose that in Kibana. So I'm going to configure this terms panel. So I'm going to click on configure again, and I'm going to flip over. I'm going to flip over to the panel tab, and right now we're in terms mode. So let's put it in terms stats mode. So terms stats mode lets me compute one field for the x-axis and another field for the y-axis. So terms stats. And I want to see an average, and I want field still to be category. So for the x-axis, I still want to see the same listing of categories I had, but instead of the count of the number of beers that appear in that, I want to look at the value field as ABV. Okay, so let's use that, and I'm going to save that. Okay, so now I can see what the average alcohol by volume is of each of these styles of beer. So looks like North American Ale roughly fits into what the average Oregon style beer is, right? They brew a lot of them. They tend to be about the average for alcohol content. So we're going to call that the average. The average Oregon style beer is a North American Ale that's about 6% alcohol. All right, that's useful. However, we're looking at all of Oregon right now, and I don't have a car while I'm here, so I need to find something local. So I'm going to look down here, and I'm going to click on brewery.city. Okay, looks like we have quite a few beers that are brewed in Portland. So let's go ahead and choose Portland. So just Portland style beers. Great. All right. Oh, interestingly, Portland doesn't brew a ton of North American ales, but I'm really interested in the overall Oregoniness of the beer, so I'm going to pick out North American ale anyway. All right, so I'm going to choose, let's see, category here, and let's pick out North American ale. Okay, perfect. Oh, I've got a big green blob there again. I don't need that. Let's go ahead and get that off my dashboard. Don't really need to know the average anymore. I know it's 6. I'll get that off my dashboard. Okay, cool. There are my listings of 12 beers. I've narrowed it down to that are North American style ales that are brewed in Portland. All right, and I want to see where they are brewed, so I'll do brewery.name. Quickly make a table of them to see who does the most of them. Raccoon Lodge and Brewpub and Hopworks Urban Breweries. Anybody been to either of those? Really? Pretty good? Which one? Hopworks is the winner here? All right, excellent. I looked them both up on Beer Advocate. They both have fantastic ratings. Good to know that Hopworks is the preferred here. We'll go ahead and just narrow it down to Hopworks. And yeah, looks like they brew some beers that are roughly in the category that we want, right? They're roughly the right amount of alcohol. I suggest you try Hopworks, and a whole bunch of other people also think you should try Hopworks if you're going to be here for a bit. Cool. All right. So that was a kind of non-time series based data set. So we've seen how we can handle. Oh, I'm down to 5 minutes. All right. I'm going to give you a very quick preview of something that we've got coming up. I'll try to make this super quick and leave a couple of minutes for questions. We've been prototyping some Kibana 4 stuff. We've got kind of a minimum viable, usable thing in that we use internally. This is actually a proof of concept that I put together a while ago to test out some of the concepts. All right, real quick, if we wanted to identify web crawlers, so I'm switching back to the Logstash dataset. If we wanted to identify web crawlers and when we were getting crawled, this is somewhat hard to do, right? Because we can't just look at the count of events over time, which is what we're looking at right now. Those are influenced by users. What we need to know is really what pages are getting hit and how many of them. Web crawlers behave differently from typical users, right? They tend to hit a whole lot of pages, a lot more than your typical user base does. So what we want to look at here is maybe say cardinality of the request field. So instead of putting count on the x-axis, I'm going to change this to cardinality of the request field. And so we can see we've got a couple of big spikes here, and I'm going to guess that those are web crawlers. How could I verify that? Well, I could sort all of my web crawlers, all of the user agents that I get into Kibana, by the number of unique requests that they make to the web server. So let's, instead of putting time stamping on the x-axis, let's change that to user agent. Oh, that turned out terribly at this resolution. Also, I have the size set to 10. Let's try setting it to 3, and if it comes out any better. There we go. All right, so the font is way too small for you to read, but it looks like whatbot and majestic 12 bot, right? So yes, we can verify that, in fact, those are all bot agents too. So indeed, web crawlers tend to hit more unique pages. And these things are very kind of composable. So let's set this back to timestamp, set that back to count, and let's say look at maybe my bandwidth bill went up. Why did it go up? Maybe the average byte size went up. Why did the average byte size go up? Let's try to figure that out. Well, let's change that to total bytes that were served. If we change x-axis to the request, wherever it is, there it is, request.raw, we can see that logstash 1.1.0 was requested a whole ton of times. Okay. Why might that happen? Well, if we change this back to timestamp, and, well, let's see, how could we identify changes in stuff? Well, let's show what user agents were contacting it, right? User agent tends to be a pretty good indication. Let's go with agent.raw, and we can kind of see here that a chef client started up on the same day. Although this is sort of hard to read because they're all kind of mixed in together. But you can imagine that we could say, show me this in rows of charts instead. So agent.row, or agent.raw, and we can see the chef clients down here. It's kind of a proof of concept of where we're going with Kibana for the future. We're really excited. This uses Elasticsearch aggregation, so they're very, very composable. That's about it. We expect it to be shipping betas soon. I'm really excited to get it out here. I hope that I can show it off at Monitorama next year. Thank you very much for your time. And that's all. Do I have any? All right, so I'm told I do have some time for questions. Anybody? Yep. What? So the way that we tend to do it is we throw a Nginx or Apache proxy in between. If you go to the Kibana GitHub repository, there are authenticated proxy examples for Nginx, Apache, and Lighty. I think the Apache one also does LDAP. So. Yep.
I saw that the percentiles are missing with the aggregators. Is there any plan for that?
Percentiles, yeah, we're going to add percentiles. That was just a very small proof of concept thing that I put together a couple of months ago, and it doesn't have all of the bucket aggregations in it yet. Anybody else? Yep.
So digging into the Lucene syntax and also some of the Elasticsearch concepts like facets, is there any good tutorial type documentation to kind of explain how that all works without having to RTFM?
Yeah, we actually have a book. It's in beta right now. I think it's on the site. It's going to be published by O'Reilly. It was written by two very talented people at Elasticsearch named Clint and Zach. And it has great documentation and tutorials for Elasticsearch functions. It's written as a proper book. It's not just API documentation. Yeah?
The beer thing is very entertaining, but I'm kind of wondering if, other than the entertaining factor, there's a reason that you showed us non-time series data, which I thought was a really interesting choice, since we've talked a lot about time series data the last couple of days. If you can elaborate more on what you see that as.
So in the future, we really want to give you the ability to relate your non-time series data to the time series data. You can imagine if you have logins or something, you don't tend to track all of the information about every single user that logs in. Usually it's stored in some sort of secondary thing. We'd really love to see you be able to relate your non-time series data to the time series stuff. So say maybe I've got an index of all of my usernames with all of their details in them. I would love to be able to link that back to each individual log and kind of populate that, or at very least provide a link for you to go see more about that user. I think that's it. All right, thanks again, everybody.